we dive right in here, trying to simplify trig expressions. The way we simplify a trig expression is we take everything we know about algebra, everything we know about trig identities, and we use that to try to come up with an answer in the most simplest form possible. So a lot of these problems to start off, and this is always a good tip to follow if you get stuck. A lot of these problems to start off, you could take any of your trig functions that are not already written this way and write them in terms of sine and cosine. So what I mean by that, we've got sine of x. Not much I can do with that in terms of writing that stuff as sine and cosine stuff, right? It's already there. But secant, tangent, we've got identities for those. So I'm going to use those here. As I rewrite my next step, the 1 plus sine of x, that's untouched. That's already in terms of sine and cosine. But secant of x. Secant of x has an identity, because it has a reciprocal, of 1 over cosine of x. That allows me to maybe simplify this a little bit further. I know it may not appear that way, but for where we're going, it might help. We're going to subtract tangent of x, which has an identity in terms of sine and cosine. Tangent of x is sine of x over cosine of x. So in case you wonder where I'm getting this information from, this is what we summarized yesterday on the back side of the first page of your packet. It's what I have basically on the sideboard as well. Now, what does that do for us? Well, anytime I encounter fractions on problems that I'm trying to simplify, it's usually a good idea to try to put those together somehow. And notice how these have the same denominator. That's going to make this pretty easy. If I put these together as one fraction, everything is going to be over the cosine of x. As far as what I have on top, well, what I have on top is 1 minus the sine of x. Those are not like terms, can't join them, so I just write them out. That simplified this part. But we still have this other guy over here to deal with. So now that I've taken this fraction expression here, put it together as one fraction, maybe it would be a good idea, since these are multiplied anyway, to try to multiply this out. Now when I multiply this out, I'm creating a fraction over here. This is over 1. So that means that basically the numerator pieces I'm multiplying together, right? Denominator pieces I'm multiplying together. If I multiply the denominator stuff together, that's straightforward, right? That's just cosine of x. But if I multiply what's on top, I have 1 plus sine of x times 1 minus sine of x, right? So let's do a little algebra. Let's FOIL. If I FOIL that out, you got 1 times 1. You got your outside of 1 times the negative sine of x. You got your inside of positive sine of x and 1. And then I've got my last terms of positive sine of x and negative sine of x. So the two sines multiply together give me sine squared of x, right? If you combine your like terms, you've got these sine of x's, right? A negative 1 and a positive 1. So they cancel. If I carry this over to the next page and write out what I have so far, I've got 1 minus sine squared of x over cosine of x. And based on our experience so far with these problems, that's a major accomplishment right there. But all we have done is algebra to get to this point. So what you have to ask yourself when you're done doing the algebra is there a way to encounter, or incorporate rather, some of the identities that we do have here on the sideboard? Well, do any of those identities stick out? A habit? There you go. There you go. A habit we want to start getting into. If we see sine squareds, cosine squareds, 1s, We see those as combinations. That identity of sine squared of x plus cosine squared of x equals 1 can probably be used somehow. Up here we've got 1 minus sine squared of x. As an extension of this identity, 1 minus sine squared of x is equal to cosine squared of x, right? So I could take this guy and replace it with this guy. When we do that, we've got cosine squared of x on top over cosine of x. Can you divide that any further? I mean, if I have something like a squared over a, can I divide that out? Sure, what is it? It's just a. So cosine squared over cosine is just going to be cosine of x. There's your simplified answer for the given expression. All right, so we consider what we just did on that first example. Carry those ideas over to here. One of the first things we did on that first example is we made sure everything was written in terms of sine and cosine. Now, this one's already there. No need to switch around using any identities at this point. But what we should notice is there's some negative angle measures. And we do have identities for those where we can get rid of that negative theta idea. So I would rewrite those using those identities. Got the sine of theta over the cosine of theta that just stays put. But I would rewrite over here cosine of negative theta as cosine of theta, because that's its identity. And on the bottom, we've got 1, well, let's see, sine of negative theta, its identity is negative sine of theta, right? So it's going to be plus since you got the minus sign in front. So that's all taken care of. Now we're ready to do some algebra. If you look at the algebra involved, you've got two fractions you're trying to add together. If we've got fractions we're trying to add together, we need common denominators. These are not common denominators, so we're going to set up one big fraction here where we multiply our two denominators together. As we multiply them together, though, let's leave them in a factored form. We do that because later on, maybe something might cancel out. All right, now we do this little cross product idea. Look at this first diagonal. I'm going to take the sine of theta, and I'm going to multiply it to 1 plus sine of theta. So I'm going to distribute that through. It's okay to distribute on top. If I take the sine of theta, distribute that through, I get the sine of theta times 1, or sine of theta, plus sine of theta times sine of theta, which is sine squared of theta. Well, that's interesting. Now if you look at your other cross product, got a pair of cosines we're matching up. So we're adding this on cosine squared of theta. If you look at the numerator, there's no like terms we can put together. So that's as simplified as we can get it for now with the algebra. But are there any identities that we could possibly use here and substitute those values in? Okay. Like I said on the last one, you start looking for combinations that have sine squareds, cosine squareds, or 1s. You're probably going to be able to use that identity that states sine squared of theta plus cosine squared of theta equals 1, right? So notice we've got that combination right here. That is all equal to 1. And if that is all equal to 1, that gives me the sine of theta plus 1 over this denominator business. There's no more identities to use here. But is there any more algebra we could do? Okay, we're looking to cancel at this point. The fraction is already together. Everything is factored out because we left our denominator alone in terms of the multiplication, right? So now it's possible we could do some canceling. And since I have common quantities of 1 plus sine of theta here, and essentially the same thing on top, those entire quantities we can take out. And if we take those out, still working down the page here, what's left in the numerator? 1. Denominator, cosine of theta. Man, you are feeling awfully good about yourself at this point that you've gotten this far. In fact, you're ready to box in that answer. You're feeling so proud. Okay, good. We see 1 over a trig function. That means a reciprocal is involved. 1 over cosine does equal secant. So now you can box in the answer.
So we'll have to memorize these identities?
All right, so problem 3 in the packet. Directions here not only talk about simplifying, but they also say we want to write things in terms of sine and cosine, then simplify. So hey, that's some advice I've already given you. Any of the trig functions you see in this expression that are not already sine or cosine, we should change over. Obviously, tangent would be one of those functions. So tangent can be rewritten as what?
Sine over.
There you go. Tangent can be written as sine of u over cosine of u. In the meantime, we are multiplying that little piece onto the sine of u. So everything's in terms of sine and cosine. Ready to, looks like, multiply some things out. If you follow your order of operations, got to multiply first. If we're multiplying fractions, well, we're multiplying our numerators. We've got sine of u times sine of u. That'd be sine squared of u. We're multiplying our denominators, cosine of u times 1. And don't forget that we've got this cosine of u over here hanging out that we need to bring down. Next in the order of operations, we've got addition. We're adding fractions. So once again, this guy would be over 1. For adding fractions, we need a common denominator, which we don't have. So we follow our little trick. Our trick that involves multiplying the denominators together first. And then doing the little cross products. So we take our cosine of u times cosine of u first. Cosine squared of u. We're adding on sine squared of u times 1. So sine squared of u. We've done all the algebra we possibly can do. We've got our fraction together. Now we look for identities, right? And oh look, there's a cosine squared and a sine squared again. They happen to be added together. That is so very convenient. Because what do they equal? They equal 1. So you have 1 over the cosine of u. At which point you feel awfully good about yourself, but wait, there's a 1 on top. So what's the answer? Okay, the answer is the reciprocal of the trig function on the bottom. So secant of u would be the answer, or as we say in French, sec u. All right, so we've skipped ahead a section here, but the goal is still the same. We're supposed to simplify. And we can still use that trick where we're rewriting trig functions in terms of sine or cosine. So I would suggest doing that on this problem. I'd take that cosecant. I'd rewrite that so it's in terms of sine or cosine. If I do that, I've got 1 plus sine of y over 1 plus. All right, how do you rewrite cosecant?
1 over sine.
1 over sine. All right, now, how do we want to go about this from here? there's a variety of ways to do this. We could notice that in the denominator, you've got this fraction plus 1. Maybe you want to find a common denominator down there, put all that together as one fraction. That's all fine and good. But another trick you could use is anytime you've got these extra fractions within a greater fraction, you could take what the denominator is down here and you could multiply that to both the numerator and denominator. Because here's what happens. If I leave the numerator as is, and remember, whatever I do to the bottom, got to do to the top. So that's why I'm multiplying the sine of y to both bottom and top. If I leave the numerator as is, it's sine of y times the quantity 1 plus sine of y. I know you might want to distribute, but hey, let's just leave that alone. Right now, we're using the sine of y to help us clear this fraction in the denominator. So in the denominator, as I multiply this sine of y through, notice what happens. You've got sine of y times 1, which is sine of y. You got sine of y times 1 over sine of y. What's going to happen with those sine of y's? They're going to cancel out, which is why we're doing this. If you're having trouble following that logic, let's think about this. I take some value, I multiply by its reciprocal. Right, all goes to 1. So that's why we can do that. Since we left the numerator in a nice, clean, factored form, notice what happens. You've got quantities shared of 1 plus sine of y and sine of y plus 1. Those cancel out. And all you're left with, sine of y. All right, if we follow what we've been following so far to start these problems, we're going to rewrite any trig functions we see that are not already there in terms of sine and cosine, right? So secant and tangent, not in terms of sine and cosine. Let's improve upon that. Cosine of x is in the numerator. That stays as is. Secant of x can be written as what? 1 over cosine of x. Plus tangent can be written as sine of x over cosine of x. Now you guys want to do that little trick I did on the last one, where we clear the fractions from within the greater fraction here?
Sure.
We do that trick. I'm going to multiply everything by cosine, since that's my little denominator values down here that are in the little fractions within the greater fraction. Whatever I do to the bottom, got to do that to the top. Okay, now on top, leaving cosine of x times cosine of x, I mean, you could do that, but you might as well multiply it together. That really doesn't matter. In the denominator, we are distributing this cosine through, and we're understanding that by doing that, the cosines that are in the denominators down here will cancel out, and that will leave us with just 1 for the first fraction, right? Plus sine of x for the second fraction. Okay, we follow so far?
Mm-hmm.
That appears to be done, doesn't it?
Sure.
This is where our creative thinking is going to start coming into play, because we know we can do better. We know stuff's supposed to cancel out somehow. I see a cosine squared. I see these cosine squares, these sine squared, these 1s. That's supposed to mean something, right? What does the cosine squared of x equal? 1 minus sine squared of x. So I'm going to replace cosine squared of x with 1 minus sine squared of x. I'm going to put that over 1 plus sine of x. Stuff is supposed to be canceling out somehow. But I can only cancel stuff if it's all factored. Is that factored? No. Can I factor it? Oh, he's drawing an arrow. That must mean something. How can I factor that? The top is a difference of 2 squares. 1 minus sine squared of x. is 1 minus sine of x times 1 plus sine of x, because that's how we factor a difference of two squares. In the denominator, we have 1 plus sine of x. At which point, everything is factored. Factored pieces that are the same we can cancel out between numerator and denominator, so 1 plus sine of x, 1 plus sine of x, all that's gone. And you are left with 1 minus sine of x as your answer. Got it?